All right. I'd like to welcome everyone to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome you all to this week's featured webinar presented by NGINX and F5. And the title of today's webinar is Advanced Kubernetes Deployment with the NGINX Ingress Controller. NGINX and F5 are regular sponsors of Developer Week, our events, our webinars, and their technology accelerates content and application delivery, improves security, facilitates availability and scalability for the busiest websites on the internet. But before we get started with speaker introductions, I'd like to remind all of our attendees that there is a live chat and Q&A available during the session, and that's to the right of your screen. And you can also raise your hand in chat and ask and answer questions in Q&A section of the webinar viewer. And Q&A, we will be covering Q&A at the end of the presentation. NGINX also has some polls planned throughout the webinar, as well as a offer at the end. So pay close attention. They have a great offer for you at the end. We will be recording this webinar, and the webinar will be available approximately 48 hours after this session, and that will be emailed out to the people who are participating, as well as anybody who registered, and so that that invitation can also be sent off to coworkers so that anybody else can take a look at this recorded session. So joining us today as our presenters for NGINX are Amir Rawdat, a technical marketing engineer with F5, and Raul Rodriguez, software engineer from F5. Amir is a technical marketing engineer at NGINX business unit at F5. He started his career as a programmer, then moved to reproducing live customer networks and data centers and building software automation tools accelerating IT operations. Raul is a software engineer for the NGINX business unit at F5. He primarily works in the design and development of the NGINX Kubernetes Ingress controller. He started his career coding web applications in Python and then moved on to cloud environments and systems. So without further delay, please give your undivided attention to Amir and Raul.
Thank you, Patrick. We appreciate DevNetwork for having Raul and I. So this presentation is going to be about advanced Kubernetes deployments with the NGINX Ingress controller. So let's get this presentation started. And first, we're going to start with a poll question. So go ahead and submit your answer.
We're getting a lot of NGINX there, so that's good.
Where do you see it in polls?
Polls and open, yeah.
Polls and open. Okay, there you go. Okay, interesting. All right. Okay, so that's cool. Let's keep going. All right. So the stats here look pretty similar to the stats I'm about to show you right now. So first, I want to step through the top 10 open source technologies running in the containers in the year of 2019. This data is pulled from Sysdig Container Usage Report. We can see that 60% of respondents said that NGINX is their top open source technology running in containers. And this makes sense given that NGINX is incredibly fast and lightweight and easy to configure, making it a perfect fit in containerized or microservices environments. Additionally, there are way over 10 million downloads of the official NGINX image on Docker Hub, and there are over 10 million Docker pulls of the Kubernetes NGINX Ingress controller. And speaking of the NGINX Ingress controller, let's look at the stats of the top Ingress providers in the year of 2018 and 2019. We can see that NGINX kept its lead here this year as the top the year of 2019 as the top Kubernetes Ingress provider. 62% of respondents chose NGINX as their top Kubernetes Ingress provider, followed by HA Proxy at 22%, and then followed by Envoy at roughly 20%, and then F5 around 10% in 2019. So it is clear that NGINX is one of the most, if not the most, popular and battle-tested Ingress controller out there. And so if we look at the NGINX Ingress provider here, there are two distinct projects out there. There's the Kubernetes NGINX Ingress controller developed by the community, and the Ingress controller developed by NGINX Incorporation. And these two projects, a few years back, hit a fork in the road, and they are moving in different directions. Traditionally, with both of these projects, you use the Kubernetes Ingress resource to provision load balancing on the Ingress controller. And now we are moving away from Ingress resources, and we are introduced NGINX Ingress resources, which is also known as custom resources defined in Kubernetes to provision your Ingress load balancing. And so with NGINX Ingress resources, we want to make it even easier for you to provision Ingress load balancing so you could move your application workloads to production Kubernetes even faster than ever before. And due to the nature of these custom resources, these Ingress capabilities enable more granularity in role-based access control and multi-tenancy. Additionally, there are many subsequent releases of our Ingress controller that include bug fixes so that security vulnerabilities can be patched as soon as possible. And new features are added, and they are stable and implemented with native C modules, as opposed to the features being extended with Lua code in the community Kubernetes Ingress controller. So this is not a matter of who is better. This is just which one you should use. But I think it's important that I outline this differentiation here before I go along with this presentation. So let's move along. So traditionally, with the Kubernetes Ingress resource, this is how you would provision the Ingress load balancing. So you'd have under the spec field the host and TLS for TLS termination and server name indication. And under the HTTP context, you have your layer 7 path-based routing to route your connections to your upstream services. And under the annotations, you see that that's where you can include your custom NGINX configuration. And so when we look at this, we see that there are some limitations with annotations. They can get quite large and complex depending on your configuration. There's no indentation. Annotations can expose security vulnerabilities, and it is difficult to troubleshoot and pinpoint validation errors once you decide to apply this Kubernetes Ingress resource to your Ingress controller. And so we are addressing these limitations with NGINX Ingress resources, which are basically custom resources in Kubernetes that you can apply to NGINX to provision advanced use cases with the Kubernetes native workflow. So in Kubernetes Ingress Controller version 1.5, we introduced two NGINX Ingress resources. One is the virtual server. The other is the virtual server route, or VS or VSR for short. And for more information on that, you can go ahead and click on this link where it will redirect you to a webinar where I talk about these custom resources in detail. And so to summarize, the virtual server is used for Ingress load balancing for domain and host name. And you can spread the Ingress configuration for a common host across multiple virtual server routes. In those virtual server routes, you can provision subroutes. And those virtual server routes can be in either the same or different namespace from the virtual server that references them. And so this enables easier management of path-based routing and cross namespacing, which means if you apply a custom resource in one namespace and you want to route the connection to a different service in another namespace, which is cross namespacing. And of course, this enables easier management of path-based routing and cross. I already said that. So these can be addressed with multiple or mergeable ingress resources, of course. But again, with annotations, you have limitations. As I mentioned in the previous slides, you get restricted RBAC capabilities when using multiple mergeable ingress resources. I will elaborate on that in the next couple of slides. And we are moving everything to the spec field in a Kubernetes indented API style to make it even easier for you to provision your load balancing as an application owner. So in addition to all that, the custom resource provides advanced content routing and traffic splitting, which is not yet supported in Ingress resources, and again, the RBAC. So in Kubernetes Ingress Controller version 1.7, we introduced an additional 2 custom resources. The first one is the global configuration, which allows you to allocate TCP UDP port numbers so that when users want to provision TCP UDP load balancing, they can use the ports that are allocated in the global configuration custom resource to listen for datagrams in the case of UDP coming to its port to go ahead and proxy those connections to DNS server pods. And we are going to step through a quick example here. So in this example, I have a global configuration custom resource in the NGINX Ingress namespace. And in the spec field, I define 2 listeners. One is both listeners listening on the same port with different names, but one is a protocol UDP and one is a protocol TCP. So once I go ahead and define these 2 listeners and I apply this global configuration, GC for short, the user can then easily provision TCP load balancing with the transport server custom resource. And he does that by referencing the listener defined in the global configuration and go ahead and proxy that connection to the DNS server pod. And so this is a much simpler way of provisioning TCP UDP load balancing. As an alternative, before you'd have to use the custom snippets in order to make this happen. Okay, so let's keep going. So now I want to talk about leveraging role-based access control with NGINX Ingress resources. So we briefly summarized that virtual server and virtual server routes can define load balancing configurations for your Ingress load balancer. So for a virtual server, you can use it to define the load balancing configuration at the domain level, and you can spread that common host domain name across multiple virtual server routes, which consist of subroutes. This is an alternative to mergeable ingress types, except over here, I have 2 separate cluster roles. One cluster role is domain LB config, and should you assign a role to a particular set of users, they can create a virtual server so they can provision ingress load balancing at the domain level all the way down to the subroute level. But a cluster role with the subdomain LB config, users assigned this role can only create virtual server routes, so they can provision subroutes that are referenced by the virtual server. So they cannot provision ingress load balancing at the domain level, but they can in fact provision advanced content routing or routing policies at the sub-route level within a namespace that you are requesting to a service within that same namespace that the virtual server route resides. And of course, if you create a role instead of a cluster role, you can make sure that the users only have those permissions in a certain namespace, which is useful for multi-tenancy as well. And if you don't want it just at the cluster-wide level, but in the namespace level. And so as you can see, this provides more granularity in providing access policies to different users and different application owners. All right, let's get to the exciting part now, circuit breaking. So in this example, we're going to use the virtual server custom resource to enable circuit breaking. So in this example, here's my virtual server. I give it a host, app.example.com, and a TLS secret for TLS termination. And I am defining an upstream service, call it app. And for this upstream service app, I'm enabling active health checks to this path URI. And so once this upstream becomes unhealthy, it will return a 502 error, at which point NGINX will, if NGINX gets a code response with one of these codes, it will go ahead and redirect that response to another URL. Otherwise, you pass it to the app upstream, which is defined right over here. So this is a simple circuit breaker pattern where if you have an unhealthy upstream, you can go ahead and redirect it to another website. And this, because this use case uses active health checks, it is exclusive to NGINX Plus. So why don't we go ahead and do a demo here. I'm going to show you guys a demo. So I'm going to go ahead and share my screen. Raul, can you see my screen?
Now it's loading. Wait, it's coming. Now we can see it, yeah.
All righty. Zoom in here. Okay.
Yeah, that's perfect.
All right. So I have a NGINX Ingress controller deployment running. Slow a little bit. There you go. It's running. And I have a service that is exposing this Ingress controller. As you can see, it has an external IP of this IP over here. So I have an app secret that I will use for the TLS termination. So I'll go ahead and apply that. That's cool. And I have a backend application that I want to deploy here.
Yeah, sorry, Amir, someone is saying if you just could zoom a little bit more.
A little bit more? Okay.
Difficult. Yeah, yeah. Sorry for the interruption.
Yeah, no problem. How about that? Is that better?
I mean, I can see it, but I just wait for someone to just confirm in the chat. Yeah. Yeah, if someone can confirm in the chat if this is good enough. Yeah, looks good. Cool.
Okay. So over here, I have a deployment. It's an NGINX web server, and it's I'm mounting an NGINX config onto it. And this NGINX config is over here. And it's basically just a simple web server config where if I have a /success, I return 200. Otherwise, with a /error 500, I return a 500 error code. And so with this deployment, I'm mounting this config. And I am deploying a service that will expose this backend application to my Ingress controller. So I will go ahead and apply this. That's cool. And then if I do a get pods, that's cool. They're up and running. So now I'm going to look into my virtual server definition. So in this virtual server definition, I define my host and TLS, my domain level load balancing config, which is app.example.com and app secret. I define my upstream, which is my backend application, which I just deployed. And I'm enabling active health checks to this path URI. And I'm saying if it fails, go ahead and send an active health check every 10 seconds. And if it fails 5 times, go ahead and label it as unhealthy. And once it's unhealthy, the upstream will return with a 502 error code, at which point NGINX will redirect the request to https://nginx.org. Otherwise, just keep on passing it to this backend application service. Before I go ahead and deploy this, I want to go ahead and, let's see, 1 second. I'm going to go ahead and do a port forward. And so we can see the activity dashboard on our browser. Go ahead and do that. There you go. And so if we go to like a browser here and we do HTTP local host 80 dashboard. All right, so here's our NGINX Plus dashboard. So let's go ahead and go back here, and our dashboard is running. So let's go ahead and apply this BS. So once I go ahead and apply that, I can now see that I have upstreams available, one of them to the 2 app pods available. And if I go ahead and try to connect to it, which is app.example.com, and then using TLS here. So there you go. This it's a self-signed certificate, so it's giving me that message. As you can see, I'm getting an HTTP error 500. So there's something wrong with the backend application, right? And so here, I see that there are 4 checks and 4 fails. So now that there are 5 checks and 5 fails, if I go ahead and refresh this, boom, I'm redirected to the nginx.org URL. And I think that brings us to the end of the demo. And of course, if you decide to scale that application service to 5, it will go ahead and update that and scale it out to 5. Okay, so that brings us to the end of that demo. So I'm going to stop sharing right now. Slides. Okay. Okay, so I hope you enjoyed that demo. And next poll question. Yeah, okay, interesting. No GCP. 0% GCP. Well, barely any, actually. 4%. All right. Well, that's pretty interesting, actually. On-prem is actually 32%. Wow. 31%. Interesting. Okay. I guess that brings us to the end of the poll. So I'm going to go ahead and give it to you, Raul.
Yep. Thanks, Amir. That was great. And I hope you people are not so bored for the NGINX Ingress resources because my part of the presentation is also about the NGINX Ingress resources. So Amir already talked about the limitations that we had when we were, adding new features into the Ingress controller, and what we end up having like pretty huge Ingress resources with a lot of annotations, and it was really difficult to keep track of them and also do validation on them. So that part is covered. So I'm gonna just talk about two of the main features that we see. They are most, two of the more that we are more proud of for the NGINX Ingress resources, which are advanced content routing and also traffic splitting. So with advanced content routing, I'm going to just jump here. What we are doing is like we are going to not only do load balancing in front of your services. So if you define for one domain that you want to route that traffic into one service, but also we are going to start doing different routing to different services depending on the request. And we offer up to 4 different methods for this routing or directing the request to the different services. One of them is do the routing based on NGINX variables. There's a list of the variables that you can use there, but for this example here, let me just try to draw here. Yeah, I guess you can see if I draw. I'm going to use a different color, red. Okay, so for example, in this virtual server that we have here, we are defining different upstreams. We have one upstream here, T post, and we have one upstream here, which is T only. And these different upstreams are going to different services. So right now here in this green part, normally what we would do here for a /T route is to define directly the action to pass those requests to an upstream and a service. But now what we are doing is like we are adding these conditions here in where we will be able to do the routing depending on certain conditions that need to be fulfilled. In this case, what we are doing is that the request method NGINX variable, which is basically the HTTP method of the request, whenever it has the value post, we are going to redirect that. We're going to, sorry, not redirect. We're going to load balance that traffic to the T post upstream. Anything else, because we always need a default option for this in case of the request is not fulfilling any of those conditions, will be redirected to T. So this could be really useful when you have different services that you want to has different needs in order to how you scale them. For example, if you have one service that is only a read service, but you want both of them to share the same path, in this case, path T, you can easily send all the requests that go with the post HTTP method to that service, and then anything else, or have more conditions here in order that you can just do that advanced routing, which is great. Another thing is based on HTTP headers, and this can be any HTTP header, not only the regular from their RFC, the standard ones, but your own headers as well. The example that I come up with here is, so again, we have the same. We have 2 services here, and we have another condition, which states that whenever we get a request with the header user agent, and this is really great, we are not only accepting strings, but also regular expression and NGINX regular expressions. So we are saying here, whenever we get a request with the user agent header, if the value has something, Android or iPhone, and then something, you're going to redirect that to the T mobile. This is one of the use cases, of course. You can be sure that your mobile customers or clients are going to one service and your desktop clients are going to a different one, or you can use any header, one application header that your front end has, for instance, which is great. And I'm pretty sure you can think of a lot of use cases for your applications right now with this. Another one is basically URL parameters. So whenever you have a URL or argument or parameter, whenever you have a URL and then you put interrogation and all those parameters there, you are able to also route traffic depending on those parameters. So in this example, we are sending all the requests that have this particular version parameter equals to 2 to the version 2 service. So again, if you have a front end that you want to do, for example, I don't know, canary releases, or you want to just have a couple of a percentage of people which you updated their front end and you want that front end to send to a particular new version of your backend, you just have to make this change, reapply the virtual server, and that's it. Boom, it's already done. And finally, finally, based on cookies. This is pretty much the same example as the headers, but this is more. This is also useful when you have like authentication or sessions in your applications, and maybe you need to. This example is not like so complicated. You know, we are just saying that the request with the cookie where the user is Bob, you are gonna redirect it to this upstream. Anything else will go to T. But think about that, what I said before, where the value here can be a regular expression. So you can be sure that, for example, any request that has the cookie authentication empty, you will redirect that to a service that just handles that unauthenticated people, and then therefore those requests won't reach the application service that you want. So yeah, these are only a couple of examples four examples that I wanted to show you about the advanced content routing, which is something that is fairly difficult to do with the current Ingress resources, and that's why we wanted to focus on this. And the other thing that I wanted to talk about is the traffic splitting. This is one of my favorites because it's really useful when you are doing A/B testing, for example. Where we are doing here, remember how this first part is the same, all the examples. But remember here, instead of splits, we had conditions before. So now we are saying is like for the path/coffee, we're going to split the traffic. There's no conditions. It doesn't matter, the request, where it's coming from, the method or cookie or header. What we want is like 90% of the requests are going to access this upstream. The other 10% are going to reach this upstream, which at the same time, they are different services. This is really useful for blue-green deployments, for example, and think about how you're doing blue-green, how people normally do blue-green deployments right now is having two different clusters and then changing the routing, before the cluster, for instance. With this, you will be able to do that as part of within your Kubernetes cluster, just by changing this YAML file or editing this Kubernetes resource directly with whichever tool you're using. So I believe the next thing is me showing the example of traffic splitting. So let me go ahead and share my screen here. Sorry. Here. And share. Yeah. Okay, Amir, can you let me know if you can see that?
I see it.
Cool, great. And this example and all of the examples this example is available in the GitHub repository, so you will be able to play with this. At the end, I'll just give the resources for this. Let's see what we have here. So for this, we're going to have, let me apply this really simple because it's easier to see. Sorry. Okay. Yeah. Okay, what we created here is two deployments with one service each. So we're going to have one deployment for the Coffee version 1 application with 2 replicas, and one deployment for the Coffee version 2 application with 2 replicas as well. Both of them are running, and the Ingress controller is also running. It's been running for a while, so stable as usual. And for this, we also created a service, 2 services, one for Coffee version 1, one for Coffee version 2, and our service to access the Ingress controller. And now the important stuff that I just showed to you. Again, we are having a regular virtual server. In this case, notice how we don't have any TLS, so I'm not using secret. I know, Amir, your example is safest than mine, but for simplicity, I'm just going to use the port 80 for this, no TLS termination. And we define the 2 upstreams here. We have the Coffee version 1 again, going to port 80 of the service, Coffee version 1, and the same for Coffee version 2, and the service, and also the port 80. So we're defining here in the routes is like we're going to do a split with a weight of 70 and 30. Again, these weights have to sum up to 100. If, for example, I put here something that is below 100 in all the sum here, or it's over 100, the Ingress controller will return an error, and this application won't be applied. And that's one of the reasons that I said before, why we moved towards these CRDs and NGINX Ingress resources, because we can control a lot of these advanced validation for this. So let's go. Let's apply this. kubectl apply and virtual server. So this is applied. I'm going to start making some requests here, and remember that we have 70% for version 1, 30% for version 2. It's not going to be like 7 out of 10 are going to reach version 1 because it's a percentage, but we should have more for version 1 than version 2. So here we have version 1 again, 1, 1. Seems like we have 100, but no. Sometimes this happens. And yeah, version 2 here. It took a little bit, but it's 70%, 30%. So 70% of chances of a request getting version 1 is a really high percentage. Good thing is we can just change this. Let's try to make version 2 90% and version 1 10%. Now we should hit version 2 like really pretty much in every request. So we applied that. And let's see what we have here. Yeah, version 2. Sorry, I think, yeah, I had an error here with the screen sharing.
Looks good. I could see it.
Amir, it looks like maybe we have lost Raul. Amir, can you hear me?
Now I can hear you, yes.
Yeah, I think we've lost Raul.
Okay, yeah, that's okay.
So
okay.
Hopefully he can hear us now, or he'll be rebooting. It's showing that he's on, but it looks like maybe he's got an issue with his bandwidth. But does it make sense maybe for you to continue on with the presentation and loop back?
Okay, sure. Yeah, I can continue on. Sure. Yeah. Okay. So what is coming in Kick 1.8? Let's step through that real quick. So in Kubernetes Ingress Controller version 1.8, you have the ability to extend your NGINX Ingress resources through snippets and custom templates. So this is useful if you're trying to apply custom NGINX configuration to your Ingress controller, and it's not available in the custom resource. But instead, you can go ahead and use snippets and custom templates to go ahead and apply that configuration to your Ingress controller. So for example, if you decide to apply the traffic splitting and the advanced content routing that Raul just covered, or the circuit breaker patterns, and say, for example, NGINX rate limiting is not available yet in custom resources, but you can go ahead and apply that in the snippets and custom templates, and it should work perfectly fine. We're also introducing IP access control lists. So we are introducing policies or custom resources that can apply IP access control policies So you can allow and deny certain IP addresses or subnets from a specific subnet of IPs. You can go ahead and block or deny them. Oh, Raul is back.
Yeah, I can take over if you want. Sorry for
that.
All
right, you can take over, sure.
Yeah, great. Sorry for that. I don't know, there was something weird with the connection, and then suddenly everything stopped working and frozen. So glad to be back. I think you were going to talk about request modifiers now. And yeah, great. So yeah, we've heard the community and all our customers and the way that there was some lacks of capabilities or features in our NGINX Ingress resources. One of them was the rewrites. So right now, starting in 1.8, you will be able to rewrite all the routes that go to different services in terms of, for example, if you are using our example of /coffee, you will be able to rewrite that /coffee to different thing, or even / as a root whenever the Ingress controller is doing load balancing for that application. Another thing that we are doing is header manipulation, not only in the requests, but also in the responses. So from now on, what you will be able to do is add, edit, or remove HTTP headers from the requests that are coming from the client or from the load balance service, which is something that we've been asked for a couple of times. And one of the most important and one of the more exciting things that we are adding is the integration with the NGINX App Protect module. This integration is only for the Ingress resources, for Kubernetes Ingress resources right now, because we want to really think ahead and know how to do this with our Ingress resources. And App Protect is the new web application framework NGINX Plus module, so it's only for NGINX Plus. And with that module, what we are trying to do, and what the team behind the App Protect is trying to do, is bring all the security to the application level layer. So you will have DevOps and DevSecOps working together and defining really secure security policies for your applications. And with the App Protect module, you won't be only able to detect those threats because of the logging in real time, but also App Protect module will block those requests depending on the policies that you define. And this is based in an F5 really well-tested module, a web application framework module, so all the signatures and everything is available. And so yeah, go ahead and check this this App Protect module for sure. So the summary, this is pretty much what we had for you today. We talked about the different Ingress controllers that use NGINX out there. We talked about all the limitations that we are trying to address with our NGINX Ingress resources. Amir also really talked about the having finer-grained access policies with the RBAC in our CRDs, custom resources or NGINX Ingress resources, and how we are moving towards that, especially with the policies that he just said that we're adding in 1.8. That's going to be a new CRD. That means it can take advantage on the different namespaces for multi-tenancy and also for RBAC for the fine-grained role-based access. Also, Amir talked about and he showed how easily it is to configure a circuit breaker patterns. And in my demo, I just show you a little bit of traffic splitting and also the content routing. Exciting news is like 1.8 is coming. It's going to be coming in the following weeks, where again, one of the main features is the NGINX App Protect integration. And a couple of resources to get you started today. Our Ingress controller is open source, both for NGINX and NGINX Plus. So you can just go ahead and check the GitHub repository where you will have all the examples, some of the examples that we just showed here, examples of the Ingress resources and examples of the NGINX Ingress resources. And we also have the two main sites in the nginx.com portal. Which one is the first one is the product itself, where you will have like a feature list and pretty much everything that we have just covered today in the beginning, and also the official documentation in docs.nginx.com, where you will have all the information regarding the Ingress controller and just links to the examples in the repository. And also, if you really want to try this with NGINX Plus, feel free to just request a free trial for NGINX Plus, and App Protect, where we'll be able to, for instance, that example that Amir just showed about the active health checks. That's one of the things that you need NGINX Plus for. requesting this trial and then going to the documentation, where you will see all the required steps to build your own image of the NGINX Plus Ingress controller for Kubernetes. And I think that's pretty much it, everything that I wanted to cover. I don't know if there's some offer, I would say, that we have to show for some swag discount. And yes, after that, I think we're ready for your questions. Yeah, here you have.
Okay. Can you hear me, Raul?
Yeah, all good.
So we're going to step through the first question. Question is, how is differ from F5 Big IP controller with NGINX Ingress controller? I think I'll take this one, Raul.
Mm-hmm.
So with F5 Big IP, you have the F5 container ingress service, which means that because of the nature of Big IP and the fact that it has a large footprint, it would sit outside of the cluster, and the control plane or the container ingress service sits inside the cluster and reconfigures Big IP on the fly as you make changes to your Kubernetes cluster. With NGINX Ingress controller, because it's lightweight and it's very well suited for containerized environments, you would just deploy it as a pod inside the cluster. With Big IP, because it has a much larger footprint, it's also much more feature rich. So really, depending on your use case and what you're trying to use it for, will really determine what will suit you best. If you're looking for, something a lot more complex, like iRules and, for example, like SAML authentication, stuff like that, then Big IP would support that. But if you're looking for something like OpenID Connect or something like that, then Ingress controller can satisfy your needs. How easy to manage the new Ingress controller against one with annotation configuration snippets? So it is pretty easy. I mean, I guess, Raul, you can answer that one.
Yeah. So what we really try to do is to provide a new way of just defining this load balancing at the Ingress level. I would say it's easier than regular Ingress resources in the sense that you don't have to go through all the annotations, but you will have a real clear understanding of what's happening in one definition of a YAML. So for example, imagine just take any other resource that you have in the Kubernetes, take a deployment, for instance, where you have replicas, you have the template for the pod, you have all of those fields, and try to change that and try to replicate that into an annotations world. It's going to be a mess because you don't have that level of connectivity or nesting. You don't have it in annotations. So think of that as a way we're going even further there, and I think we've really put a lot of effort in trying to define and organize all the layers and all the nested keys there in a way that makes sense. Also, the positive aspect is we are trying to be as faithful as possible to the final NGINX configuration. So if you go to a virtual server, you will see how we define the upstreams first, and then we define the routes, which are the locations for NGINX. So if you have a little bit of knowledge of NGINX configuration, that would be really easy for you to understand, all those relationships. So I would say maybe it's a little bit hard at the beginning because you are not used to them, but once you start learning them, I think they really present a better, more faithful, understanding view of what's happening in your cluster, which I think is better. Yeah. I don't know if you agree, Amir.
Thank you, Raul. Yeah, no, I definitely agree. I definitely prefer custom resources over annotations any day.
Yeah. The next one is kind of similar. It's about how difficult it is to transfer the Ingress to NGINX Ingress resource. So I'm just gonna finish this part by saying that basically the three main points that were in the Ingress resource were TLS termination, host-based routing, and path-based routing. So those three are fairly easy, really easy to transform into our virtual server resources because they kind of have one-to-one relationship. So that part is covered. That part is really simple. Again, passing from annotations to something different, that will depend on how we define it, the CRD. We try to make it really easy for the end customer, for you. So I think it depends. If your Ingress resort has, I don't know, 20, 30 annotations, the part of the routing is going to be easy. The part of the annotations may take a little bit. If you are, free of annotations or only have one or two, that's going to take you like, I don't know, 10 to 15 seconds at most. It's really, really simple. Yeah.
All right. And one more, could those YAML files be made available online along with the recording? So many of the YAML files are available, like Raul said, on the GitHub repository. You can see examples. And of course, from there, I mean, you can look at this recording to review what we applied. And again, you can look through our documentation and see all the fields that are available and play around with it as well.
And Amir and Raul, is there email addresses for either of you that you would like to list out so that the attendees can ask any additional questions direct to you via email?
Sure. Yeah. Should I write it in the chat?
Sure, that would be great if you could do that. So if anybody wants to directly connect with Amir or Raul after the fact, they're going to put in their email addresses right into the chat. So take a look at that and grab that as well. Before we finish today, I'd like to thank Amir and Raul and the NGINX F5 for their sponsorship of today's online learning session. And I wanted to remind all of our attendees that, again, the recording will be available about 48 hours after the fact. It will be emailed to you. You can also then email it out to any coworkers, anybody else that you are, or colleagues that you might find it interesting. But they can also go to our devnetwork.com website, where we have an archive of all of our webinars, including this great webinar. And there was another webinar by NGINX F5 about a month and a half ago, which is also can be found at devnetwork.com. So I just wanted to say thank you, both of you, for participating today, and all of our attendees for participating. And I just want to wish everybody a great and happy and healthy day. Bye now.
Thank you. Bye.